250 species in genus Vicia. My fascination with Vecias, Vicia. As a botanist, I've always been drawn to the Fabaceae family, a diverse group of flowering plants that includes beans, peas, and lentils. But within this vast family, it's the genus Vicia, commonly known as Vecias, that truly captivates me. These climbing or trailing plants, with their delicate tendrils and vibrant flowers, are a testament to nature's ingenuity and beauty. Vicia are found across the globe, thriving in a variety of habitats from temperate grasslands to subtropical mountains. Their adaptability is a testament to their resilience and evolutionary success. What truly sets them apart, however, is their ability to form symbiotic relationships with nitrogen-fixing bacteria in the soil. This unique partnership allows Vecias to enrich the soil, making them valuable allies in sustainable agriculture and ecological restoration. A diverse genus. The genus Vicia boasts over 250 recognized species, each with its own unique characteristics and ecological niche. See full list at monsteraholic.com. The importance of Vecias. Beyond their ecological significance, Vecias also hold immense economic and cultural value. For centuries, they have been cultivated as a source of food, fodder, and green manure. Their ability to improve soil fertility and suppress weeds has made them indispensable in sustainable agriculture practices. In recent years, there has been a growing interest in the potential of Vecias for phytoremediation, a process that uses plants to remove pollutants from the environment. Some Vicia species have shown promise in absorbing heavy metals from contaminated soils, offering a natural and sustainable solution for environmental cleanup. My ongoing research. My current research focuses on the genetic diversity of Vicia species and their potential for adaptation to climate change. By understanding the genetic makeup of these plants, we can identify traits that confer resilience to drought, heat, and other environmental stressors. This knowledge can then be used to develop new varieties that are better equipped to thrive in a changing climate. I am also exploring the use of Vecias in intercropping systems, where they are grown alongside other crops to enhance productivity and reduce the need for synthetic fertilizers and pesticides. Preliminary results suggest that intercropping with Vecias can improve yields of companion crops while also enhancing soil health and biodiversity. Looking ahead, the genus Vicia holds immense promise for sustainable agriculture, ecological restoration, and even environmental remediation. As we continue to face challenges such as climate change and food security, these versatile plants offer valuable solutions. I am excited to continue my research and contribute to a deeper understanding of this fascinating genus, ensuring that Vecias continue to play a vital role in our world for generations to come.